Loudspeaker and Room System Analyzer, or LARSA, is a powerful impulse measurement and analysis tool. It is ideally suited for measuring loudspeakers in rooms, multi-speaker setups, car audio systems, home theater systems, or larger installed loudspeaker systems. It is an easy way to profile a system and give you the information you need to equalize or tune your loudspeakers for best possible performance in your listening space. LARSA brings complete measurement power and convenience previously available only on desktop computers. LARSA is available as a standalone application and also as an in-app upgrade for audio tools. The first step will be to take a reference measurement to determine the baseline latency of my loudspeaker and measurement system. For this demo, I have a measurement microphone attached to my iAudio Interface 2 and the output driving a small studio monitor. You can also use the internal mic of your iOS device. In this case, you would use a 1/8 inch 3-conductor cable terminated in connectors for your system. If the cable has left and right connectors, make sure you select mono mode for the output signal. The same setup will work with our iTest mic. Just make sure that you plug in the output cable after iTest mic has been recognized by the app. For best results, make sure there are no other audio apps running in the background on your iOS device. I'll tap the wrench icon and ensure that my latency box is set to 0 seconds to start. Tap Done and place the microphone as close as you can to the transducer you wish to measure. Tap the measure button and take your first measurement. A log sine sweep signal will be played from the output and the input sound will be recorded. Through a process known as deconvolution, the resulting impulse response will be generated. To set the latency, switch from the analysis curve screens to the ETC screen. The ETC, or energy time curve, shows how energy is decaying in your room. First, make sure that the 1-second option is selected in the ETC graph. Use a single finger drag to slide the cursor to the peak of the impulse response and observe the time readout. This is the reference latency of your system. Tap the wrench icon again and type the value you observe into the latency field. Now take another measurement in the same reference location. This time, tap the 0.020 second button on the ETC curves graph. Your new measurement's peak should be near 0 milliseconds. If you need to correct the latency, do that now. Once that is set, as you move around your room and make other measurements, the delays and distance differences will be meaningful. There are two basic ways to use LARSA. The first is to make individual measurements of different loudspeakers or measurement locations around your room. The other is to make multiple spatially averaged measurements of the same loudspeaker. We will start with the first case where you wish to measure, for example, a small studio monitor in 1, a close microphone configuration, 2, at the listening location, and 3, at a location in the diffuse field. You have two options for sweep lengths, which can be selected in the setup screen. The 0.5 second sweep gives you good resolution and a quick measurement time. The 1.5 second sweep gives you a little bit more resolution in the low frequencies, which is useful if you are measuring large loudspeakers that have an extended low frequency response or subwoofers. Now we are ready to take a measurement. Tap the 1 test number and position the microphone in the close microphone configuration. Now tap Measure. In the Analysis Curves graph, you will see the frequency response of your measurement. The currently selected measurement and the test number will be displayed as a blue trace. Test numbers that have a stored IR will be displayed in green text, and open locations will be displayed in red text. The average shows the average frequency response of all measurements. The frequency response graph can also be smoothed. In the setup screen, there are options for the frequency graph. Curve smoothing options from none to full octave smoothing are available. You can also manually set the ranges for the dB axis or frequency axis instead of using the touch GUI to adjust the graph. Turning on lock graph ranges will prevent any changes other than vertical panning of the plots. Next, I will move the microphone to the listening position and repeat the measurement process. Notice how the intensity of the frequency response has decreased because I am further away from the loudspeaker. In LARSA, none of the responses are normalized, so you can see the level differences and time differences in multiple measurements around your room. Now I will move over to the ETC curves plot and see that the second IR we've measured is further back in time than the close mic IR. This is because there is a delay introduced by the distance from the loudspeaker to the microphone. Dragging a finger onto the plot will let me measure this delay. Now I'll move my microphone to the third measurement location and repeat the process. You can repeat this process for up to 8 measurement locations in the room. To store your results, tap the folder icon. For complete save recall instructions, please refer to the info in this screen. A useful technique for characterizing how a loudspeaker sounds in a room is to measure a spatial average around the sweet spot. The technique here is to measure IRs around the listening location and take an average. This helps to smooth out modal behavior and gives you a reasonable impression of the frequency response that you are actually hearing from your loudspeaker. This technique is useful for setting tone controls on a preamp or receiver, or general equalization of your system. This is also a useful technique for setting the EQ settings present on many active studio monitors or DSP equalizers. Start again by setting your latency as demoed before. Tap test number 1 and place the microphone where the location prompt shows you, with the microphone pointed up at ear level. Continue the process for the remaining 7 measurements. Then tap the average button. This is now a reasonable approximation of the frequency response of your loudspeaker in your room, and may be used as a guide for adjusting the equalization in your room. After an IR is recorded, it is windowed in the time domain to reduce errors in the frequency response due to the abrupt stopping and starting of the IR sound file. Windowing smoothly removes some of the beginning and the end of the IR. Since most loudspeaker systems are being measured in rooms with relatively short reverberation times, this has minimal impact on the resulting ETC analysis. There are 3 options for time windowing. They can be adjusted in the setup screen. The options for adjusting the time of the window are available for short, medium, and long windows. You also have the option to disable the time windowing, which can be useful for inspecting the noise floor and signal-to-noise ratio of your system. In the Setup menu, there are options for adjusting the display of the ETC graph. You can manually set the dB scale and time scale. Here you can also set your system latency as discussed in the Basic Setup section. Options are here as well to express the x-axis in units of time or distance. Start measuring and optimizing your speakers and room with the LARSA app and the LARSA module for Audio Tools. Audio Tools is the premier test and measurement app for iOS. The LARSA app and the LARSA module of Audio Tools work on all current generation iOS devices and work with all audio input devices supported by the hardware.